Welcome to our poster entitled Copper Sulfide Nanocrystals as an Alternative Plasmonic Material. Copper sulfide is a mineral which, owing to its crystal structure, has very interesting properties that render it as an advantageous alternative to conventional plasmonic materials. These properties include a natural hyperbolicity in the optical visible spectrum, while at the same time also being anisotropic and plasmonic in the near infrared. Subsequently, these nanocrystals show a dominant localized surface plasmon resonance in the near infrared, which has been demonstrated to be widely tunable by changing the size and shape of the nanoparticles, and its range can be between 800 to 1600 nanometers. This range ideally places copper sulfide in a desirable position, filling the gap between conventional metal and metal nitrides operating in the visible and conductive oxides beyond 1500 nanometers. In this poster, we further also demonstrate our study of large scale thin uniform films of copper sulfide nanocrystals. We use two very different methods of fabrication, one being electrophoretic deposition and the other using chemical functionalization of the substrate to bond with the nanoparticles. Through both these methods, we were able to make smooth, thin films which we then use for various optical characterizations. Interestingly, the extracted optical permittivity of the effective medium of these thin films predictably had a plasmonic character to it, and we subsequently demonstrate the presence of surface plasmons on these nanocrystal films. We further show interesting physics of thermalization of hot carriers in copper sulfide bulk and nanocrystals using pump and probe transient measurements. The result shows that thermalization happens faster in copper sulfide compared to conventional metals owing to the lower carrier density in copper sulfide. We also detect coherent optical phonons in the bulk CuS crystals as well as in the nanocrystal films. Finally, we also demonstrate experimentally that the LSPR in copper sulfide nanocrystals can be tuned in a wide range and with a good reproducibility by doping these particles with zinc using an ion exchange synthesis procedure. The resulting particles show a consistent redshift in their LSPR peaks as the ion exchange synthesis temperature was increased, which we attribute to increased zinc doping. So if you want to learn more about these characteristics of copper sulfide, about the thin film fabrication, about the pump probe transient measurements and the interesting physics, and how to tune these particles to more red shifting resonance, please visit our poster. Thank you.